Okay, if m times the nth term of an AP is equal to n times the nth term and m not equal to n, show that m plus n term equal to 0. That is, we have mth term is equal to, as usual, a plus m minus 1 into d, right? Where a is the first term and d is the common difference. Similarly, an would be equal to a plus n minus 1 into d, right? And we have said that m times the mth term is equal to n times the nth term. That is, a plus m minus 1 into d is equal to n into a plus n minus 1 into d, right? Okay, let us expand it on both sides. We will get a plus m into d, m minus 1 into d becomes md minus d is equal to n into a plus nd minus g, right? When expanding it again, we'll reach at a plus md minus d is equal to an plus n square d minus nd, right? But we have m into a plus n minus 1 into d, right? Therefore, it will become ma plus m square d minus md. ma plus m square d minus md. Okay. Then, on rearranging these things, taking all the things on one side, we'll get ma plus m square d minus md minus n into a plus n. When it comes to the other side, the plus sign will become negative. Therefore, minus n square d plus nd equal to 0, right? Taking the common terms together, it will become a into m minus n, right? Plus d into m square minus n square. Again, my d into plus g into minus m plus n equal to 0. In both these terms, again d is a common factor. Therefore, a into m minus n plus d into m square minus n square minus m plus n, okay, equal to 0. Or we have a into m minus n plus d into m square minus n square can be written together, m square minus n square. Then taking the minus out, we get minus of m minus n, right, equal to 0. Therefore, a into m minus n plus d into m square minus n square is m plus n into m minus n, right? Minus d should be given here also, d into m minus n equal to 0. All the three terms contain m minus n as a common term. Therefore, taking it on the other side, it will become 0 by m minus n. That is, we take m minus n as a common factor, m minus n into a plus d minus d, a plus g into m plus n minus d equal to 0, right? The m minus n, when coming to this side, we will get a plus m plus n into d minus g equal to 0. Okay. From both these terms, again d is common. Therefore, a plus d into m plus n minus 1 equal to 0. This is in the very similar form of a plus n minus 1 into d, where n minus 1 is a term, m plus n together. Therefore a plus n where n is m plus n minus 1 into d equal to 0. That means m plus nth term equal to 0. Now the next question is, if sum of first four terms of an AP is 32 and the ratio of the products of the first and the fourth to the second and the third terms is 7/15, find the AP. In such a case where the sum of 4 terms is given, we'll take the terms as, for a simple method of doing, we'll take the terms as a minus 3d, a minus g, a plus d, and a plus 3d. We take the AP as this when it comes as an even number of terms. Like here we have 4 terms, right? Therefore the first term we will take as a minus 3d, second as a minus g, then a plus g, and then a plus 3d, where the common difference would be 2d. Common difference g will be equal to 2 into small d. Okay. If we are asking the question about the sum of 3 terms or any odd number of terms, we will take a minus g, a plus g, etc. Okay, this is for additional information, so keep it in mind. And here we are given that the sum is equal to 32, right? So we will take a minus 3d plus a minus g plus a plus g plus a plus 3d. It would become 32, right? A minus 3d plus a minus g plus a plus d plus a plus 3d would become 32, or 3 minus 3d and plus 3d gets cancelled, minus g plus g. Therefore 1 2 3 4 4a is equal to 32, or a equal to 8, right? 32 by 8. But we have to bear in mind that here a is not the first term. The first term is a minus 3d. So to find the first term, we have to find the d also. Then we have to get the common difference as 2d. Okay. Therefore a is equal to 8. Now we are given the ratio between the products of first term and fourth term to the products of the second term and third term is equal to 7/15, right? Therefore a1 is equal to a minus 3d, right? We have taken the first term as a minus 3d. Therefore a minus 3d into fourth term is a plus 3d. A plus 3d by a minus g into a plus g would give a sum of 7/15, right? Therefore this is in the form a plus b into a minus b, right? That is a square minus b square. That is a square minus 3d the whole square by, it is again the form a plus b into a minus b. Therefore it is a square minus g square is equal to 7/15. That is a square minus 9d square by a square minus g square is equal to 7/15. On cross multiplying, 15 into a square minus 9d square equal to 7 into a square minus g square. On simplifying, we get that 15 a square minus 15 into 9 is 135. 135 d square is equal to 7 a square minus 7 d square. On taking the terms with a square on one side and d square on the other side, we'll get 15 minus 7 into a square would be equal to 135 minus 7 into d square, right? We already have a equal to 8. Therefore 15 minus a 7 is equal to 8. Therefore, 8 into 8 square is equal to 128 d square, or d square would be equal to, this would give us 512 by 128, or d square is 4, or d can be plus or minus 2, right? D is plus or minus 2. Therefore, the common difference we have already taken. Common difference is equal to 2 into d. Therefore, the common difference would be equal to plus or minus 4 actually. Okay. Then what would be the AP? We have the AP as taken as a minus 3d, or a minus g, and a plus g, and a plus 3d, right? Therefore, we have already found out that a is equal to 8 and small d is equal to plus or minus 2. Therefore, the probability of AP that can be in one form, the first type of AP would be 8 minus 3 into 2. When d is equal to plus 2, we get the AP as a would be 8. 8 minus 3 into 2, 6. That would be 2. Then 8 minus 6 would be, 8 minus 2 would be 6. Then it would be 10. Then 14, etc. Or else when the d is equal to minus 2, the AP would be a minus 3 into minus 2. Right? 3 into minus 2 becomes minus 6. Above 8 plus 6. It would become 14, 10, 6, 2, etc.